uses in statistics and probability. Like if you want to generate a random variable x according to f of x, you go to a book of random numbers, u, and calculate f inverse of u. And that'll have the desired distribution. So here's the proof. We want probability that u is less than or equal to u. That is, this is f of u. F of u. Little u is this. All right, well, that's the probability that f of x, that's what u is less than or equal to little u. Now, f is monotonic. Let's take f inverse of both sides, and that will preserve the inequality. So this is the probability that x is less than f inverse. F inverse of u. Now, little u is just a number. F inverse of u is just a number. So the probability that the random variable x is less than this number is f of that number. So that's f of the thing on the right-hand side, which is f inverse of u. But f of f inverse is the identity. So this is equal to u. And if you kept track of when this made sense, it's for 0 less than u, less than or equal to 1. And indeed, it's precisely the distribution function of a uniform 0, 1 random variable. So that's very nice. By the way, a side remark. F inverse of a uniform if we write x equals f inverse of a uniform, then that implies that x has distribution f of x. So that's just same math. So this is how you use random number generator to generate a random variable x having this distribution. By the way, when you say this in words, you say f of x is the quantile that x falls in. And you're just saying that 80% of the outcomes, x, fall on or below the 80% quantile, right? But 90% of the people fall below, are in the bottom 90%. And 5% are left, fall in the bottom 5%. So that's all that this theorem says. You're just changing x into the quantile associated with it, the way they do on the GREs and the SATs. By the way, I wish they would change the GREs. You all took them, and you all got, essentially, top score. They aren't trying to break the ties among the top 6% or so of the people who take the exam. And I'll have to say that there are some schools that are interested in breaking that tie. So I wish they would give a little more detail up at the top. Okay, now for the arithmetic coding. Then we'll let X take values in this D area alphabet. Let Xi be a stochastic process. Over this alphabet. And an example, English text, text, music, IID, or Markov, they're all examples. But arithmetic coding will work for all of them. Let X equal point X1, X2, X3 to the base D. This isn't essential. All we need is a linear ordering of all the texts. For example, the name ABA precedes ABM, if that's a name, because although they agree in the first places, they first disagree in the third, and A is less than M. So that's an ordering, but here's a good way to order them. Just write them down and interpret it as a number between 0 and 1 in the unit interval. It's a concrete way to do it. This part is not essential to arithmetic coding. Then, let U equal F of X. All right, so here's X that we get from the stochastic process. And associated with this stochastic process is a cumulative distribution function, cap F. U equals F of X. The no atoms assumption says there's no infinite sequence here that has strictly positive probability. For example, if I flip coins after n trials, they have probabilities like p to the n, or p to the k, q to the n minus k, all the way through q to the n. Those all go to 0 as n tends to infinity. So if I did this for a Bernoulli p process, I would find that the cumulative distribution function for it had no atoms. Then use map. Of x1, x2, x3, etc. maps into u1, u2, u3 here, I guess I'll put it 2, and this is 2. So the map is u equals f of x. So I take this stochastic process and I get here a Bernoulli half process. Perfectly incompressible. You cannot compress this any further. By the way, from time to time, you will see an advertisement for a data compression algorithm or device that will say, we're able to achieve a compression ratio of 4:1 on any sequence. Would you buy such a device? Would you buy it? Well, it'll give you 4:1 on any sequence. Well, I advise you to buy 2 of these devices. The first device will compress this 4:1 into Bernoulli a half. And then the second device will take the Bernoulli a half and compress it 4:1, which of course it's probably not going to be able to do. But if it could, you could take War and Peace by Tolstoy and reduce it to 1/4 of its length, and then to a 16th, etc., until you are down to a single symbol, which suggests that there would only be 27 works of literature out there, and Tolstoy got there first. Okay, let's take a 4-minute break, and then I will show you how easy it is to implement this on the fly. 4-minute break. Okay, as I mentioned, the solutions to homework set 4 are here. So if you've turned in homework